Hello, welcome back. I'm taking a break from games to show a mathematical proof, in quotes, that's somewhat dear to my heart. Proof that 1 equals 0. Now there's the basic one that x equals 1, subtract 1 from both sides, then divide by x minus 1. 1 equals 0, but that's a division by 0, which is boring and a well-known exploit because math breaks down around 0 and 1, depending on which formulas you're using. So how about without dividing by 0? Minus 1 can be either 1 divided by minus 1 or minus 1 divided by 1. Both compute to minus 1, correct? So let's take the square root of both sides and then distribute the square root. Just keep typing the E at the end of words for some reason. No idea why. Okay, so calculating that, I get 1 divided by I equals I divided by 1. I is the square root of negative 1, for those who don't know. So let's multiply both sides by the same value. The imaginary value is square root of negative 1, which is I. Cancel the denominator here. Denominator is 1 over here, so I don't care. 1 equals I to the 2. 1 equals negative 1. Just do a little bit of tidying to get 1 equals 0. So, what's the problem with that? Do you see the issue? 2. The issue is I did not preserve the phase. When working in just real numbers, 1, negative 1, 0, 2, 3, 4, negative 2, negative 3, negative 4. As long as I do not take the square root of negative numbers, it works out. The catch is, I did exactly that. I brought complex numbers into it. Well, imaginary numbers. For example, that 1 that I got over here in the I squared. The 1 is over here. I squared starts here, goes over to here. But because I did 1 divided by minus 1 and minus 1 divided by 1, although their vector, although the distance they travel from the origin is the same, and although they both end up here, their phase is different. One of them ends up over here at 1i, the other ends up at below the drawing at minus 1i. They are completely different. It was in that moment when I did this that this step here made this step invalid. Because I brought in the imaginary numbers. That's what the problem is. The square root function halves the phase. For example, minus 1's phase halves from pi radians or 180 degrees to pi halves radians or 90 degrees. The square root of 1i would then go to square root of 2 over 2 plus comma. Will be 1 at 45 degrees. Or written in coordinate form, it would be square root of 2 over 2 of 1 comma I. So yeah, always make sure to check your work. Always make sure to check for the edge cases, like, say, divide by 0 or other things. Not a game, but an interesting mathematical trick that I thought would be fun to share. Thank you for watching and have a good day. This is the Naismith, signing out.